Moving from a single source of truth to a single point of access upends decades of conventions in the big data world. For this reason, understanding the true freedom of data federation can take time and might involve pushing against certain preconceptions. This is particularly true when we consider data federation using a modern data lake or data lakehouse, a technology built in the same cloud object storage used in traditional data lakes, but with a better performance and improved functionality, approximating a data warehouse. Because they're versatile, capable, and inexpensive, modern data lakes fit a position in the emerging data ecosystem as a data warehouse replacement that can still work alongside data warehouses and other data sources if necessary. How did we get here? Not too long ago, inexpensive but performant storage was only a pipe dream. Let's roll back so we can understand how data lake federation works. In the past, no matter what data system was being used, the typical approach was to add all of your data from multiple sources to a single data warehouse as a starting point. From there, analysis could happen only after all sources had been moved to the warehouse, and after that data had been transformed entirely using ETL. But all of that has changed, and today data lakes are the center of gravity in many organizations' data strategy, and a single source of truth is being replaced with the new love of plurality. Like any big change, it's happened for several reasons. The first change was the emergence of a data lake analytics platform that makes easy access and federation possible in the first place. In our case, that's Starburst Galaxy, making use of the massively parallel processing engine Trino to deliver previously complex data interactions with ease. The second is the development of modern data lakes themselves, particularly those making use of cloud object storage using Iceberg and other open table formats. So how do you federate a data lake? Data federation is a data management technique that involves accessing data from multiple, disparate sources as if they were a unified single source. This means that data from multiple sources can be integrated in near real time using data virtualization techniques that make data accessible wherever it is held. Rather than physically moving or replicating the data, data federation creates a virtual, logical layer that sits on top of the disparate data sources, providing a unified view without actually consolidating data in a single place, as we have in the past. Queries and analysis can take place from this single point of access. At all times, this process is managed by security and access control, and in Starburst Galaxy, both role-based and attribute-based access control help ensure that the right data is accessed from the right data source by the right people. If the answer to the question, what is data federation, seems revolutionary, the answer to another question, what does data federation achieve, is equally revolutionary. Data federation breaks down the implicit hierarchy associated with one data source over the other. Because data is no longer forced to exist in only one kind of data source, the choice of which data source becomes more open. Organizations optimize for cost and performance, not just centrality. For example, since modern data lakes are both highly performant and cost-effective, most data can be stored there, while legacy data that cannot be moved for governance, compliance, or technical reasons can be retained in its original source. Meanwhile, data warehouses can be used sparingly, if at all, as special use cases suited to particular scenarios only. Such an approach would save vast sums of money. No matter which cloud provider you use, whether AWS, Azure, or GCP, data lake cloud object storage is highly cost-effective and highly scalable compared to data warehouses. Extra resources can be added quickly, and compared to the technologies of the past, object storage is inexpensive, accessible, and plentiful. Excited? The next video will dive into a scenario where data federation might be used involving a modern data lake and investigate how federation can maintain efficiency while saving money and supporting unstructured data.